Welcome everyone to the first kind of proper technical workshop of the Encode Polkadot Hackathon. I'm Anthony, founder of Encode Club, and today we have a very good workshop in store for you. We have kind of two hats on here, both SubQuery and on Finality, which sit under the same broad roof. We're going to have a presentation on both of them today, and James and Tre are going to take you through everything that you might need to know. And if you have any questions, please do put them into chat. And otherwise, we'll put in a ton of resources on the chat as well. If you do have any other questions in general about the hackathon, the best place to go is the Discord. There's the dedicated Polkadot Hackathon channel, and we can find out everything you might need to find out about or ask any questions. Without further delay, James and Tre, great to have you, and handing over to you.
Awesome. Hey, thank you very much for having us, Anthony. And I'll hand over to Tre for most of this session. He's a man on the screen share, so Tre.
Hello, everybody. How are you all doing? First off, I am Tre. I am here in the States. I am the community manager / North American business development head here for SubQuery, and I will be walking you through just a little workshop about SubQuery, kind of going over everything about SubQuery projects, and then of course letting you guys build and go through our own SubQuery project itself. So on the agenda, like I said, we have the introduction. We're going to go through some of the basic concepts of a SubQuery project. That is the manifest file, schema file mappings. I'll go into depth of those later on, and then we'll go ahead and build a simple project, and then we'll actually build a more advanced project that is it goes through and finds different transfers and balances on Polkadot itself, and so it'll give you guys some good experience on how to actually use SubQuery projects and format them to actually pull data on chain. And last, we'll talk through SubQuery projects with our own hosted infrastructure, and then we'll open it up to a Q&A after that. And so what is SubQuery? Well, as you can see on the screen, SubQuery is an open source project that allows developers to index, transform, and query substrate chain data to power their applications. So first off, you can think of it like a Google for blockchain, where we're indexing a lot of data and information so people can go and query the data very fast. Another reasonable comparison is to the graph, if you know of them on Ethereum. We are similar to them, but on Polkadot. We've been with Polkadot and Substrate since day one. And so that's how it allows us to not only tackle the Polkadot ecosystem, but any substrate-based blockchain that is all parachains and the sort, because of our commitment to Substrate currently. And James, real quick, if you wanted to go over on Finality.
Yeah, sure. So as Anthony mentioned, On Finality is another team that we're part of. I don't have a slide for this, sorry. But we are the largest infrastructure provider in Polkadot. So we're very much like Infura for the Ethereum space. When you're working on the hackathon, if you want access to RPC endpoints to any parachain on Polkadot, or if you want to deploy your own kind of builds to a managed environment, On Finality can help you. So go online to On Finality, and you can get real-time endpoints. I'll show you some examples in SubQuery here. But there's both projects which are both really kind of designed to provide tools for developers as they build new applications. Both of them we kind of help manage and build, because that's really our kind of universal goal in this organization, is really to build projects that help other developers. So yeah.
Awesome. Yeah, thank you, James. And so quickly, what is needed to actually run a SubQuery project? Well, very basic things. So all you really need is Node.js or the Node Package Manager, NPM. There's a lot of resources how to install that online. We're going to go off the assumption that you know how to install it. If not, just type in Node.js and download it, or you can use, Brew, just a Brew install node to get that. But the main thing you'll need here is our SubQL command line interface, and that's just run with the command seen on screen, npm install the global tag for add SubQL /CLI.
Just for everyone's point, on the call here, we're going to write up a workshop set of notes, and then as you can if you watch this, you can then try it again yourself with some set of instructions that we'll send out after.
Yes, and everything we go through today, we'll post that code up as well, so you'll have a reference as well. And Yarn here, you can download it optionally. I will personally be using it for the scripts that we run. The Yarn install for SubQuery is a little wonky with the dependencies. That's why I recommend installing the CLI with Node. But you can do any of this. You can run any of the scripts using Yarn. That's what I will be doing through this walkthrough. And then lastly, Docker. So Docker can be a pain, especially from Windows like myself sometimes, but you can use that and you can make your own Docker container that we can then locally run a SubQuery project, so you don't have to worry about setting up the nodes things. You can use a Docker container that has all of that, where you can actually play around with your project locally. So you can, I guess, go ahead and start installing those if you don't have it, as I move through some of the introduction of a SubQuery project specifically. So what are the basic components of a SubQuery project? Well, essentially, a SubQuery project itself is just a set of instructions on how to index data. So the three main files that you'll be editing just alter how you'll be writing those instructions, and then how you'll be grabbing and then loading, or extracting, loading, or transforming and loading that data as well. So the first one is the GraphQL schema file. So this is essentially the shape of your data. If you're familiar with databases and so, it's similar to a schema file there, where you're just making the shape, you're making an entity that all your data will be kind of shaped around. Next, we'll have the manifest file, which is essentially just a configuration file. This is where you can define what endpoints you'll be referencing and putting in your own custom endpoints for whatever blockchain. And then here also you can define what how your SubQuery project will be going through the blockchain, whether you're going block by block using a block handler, or if you're looking for specific events and so forth. So that will be explained in the next slide, but it's just a configuration. And then lastly is the mappings file. This is the engine room. This is the actual data transformation pipeline, where you can add your own custom functions. You can aggregate, you can do whatever you would like to your data before you save it into your database for indexing later, for querying later. So that's where the main bulk of the coding comes into place with SubQuery project. And so real quick, I'll go through the different handler types. These are all pulled from Substrate, but there's the block handler, and as you can guess, it just goes block by block. So all pre-existing blocks, and then any new block created, it'll grab data from each of those blocks. Next, we have the event handler. So this is where we go through and grab every event that we can filter using that manifest file. And so we're pulling specific events that we want here. In this case, we're pulling balances.deposit, but this can be any event that is publicly available on Substrate using their API, and I can show you that later as well. And then lastly, there's also call handler. So these can even filter even further down, where you can get extrinsic calls made on Substrate. So the individual extrinsics inside each event. So the more specific you get with these filters, the more performant your application, your SubQuery project will be, because there's less data that your project has to go through when pulling data. And so now we're going to go ahead and actually build a project together. So this will be a hands-on exercise where we will build a project called SubQuery Transfers, and we'll just essentially look through and find the transactions made on the Substrate mainnet, Polkadot mainnet, apologies. So we'll first, define the shape of our data using the schema file. We'll update our handlers in the manifest file, the project.yaml file, and then we'll update the mappings. So this is essentially just give you an idea of how those three main files kind of work with each other. And it'll give you guys an idea of how to build a useful SubQuery project. So there's a lab workbook. I think we'll be supplying that afterwards. So I'll kind of break down each step independently, but with that, here I have Visual Studio Code open. And all we have to do, I'm going to go ahead and open up the built-in terminal. So the first command you'll have to do is subql init. This is the initialization command, and it defaults to our starter project. And I'll give this a name. We'll just do subql list transactions. So the name is nice to have, of course, but the Git repository is actually optional. For now, the RPC endpoint will default to the Polkadot API endpoint is hosted on
And this is
OnFinality.
also important to notice. This is the OnFinality endpoint. So again, we run public API endpoints, and we've by default put in the Polkadot API endpoint into this.
Sorry, I'm having some trouble with my audio.
No, you can carry on, Trey.
Okay, sorry, I'm back. Yep, apologize about that. So I didn't quite hear what James said, but I'm sure it was helpful. I'll just move on. Good to go.
You can carry on, Trey.
Okay, I apologize about that. Yeah, so authors is mandatory. I'll put my initials there. Description optional, version will default to 1. And then by default, we use the Apache 2.0 license. So with that, we now have a project initialized. You can see that on the left. I'll actually run into it and then open this up. So here, we now have a bunch of things that were generated. Of course, we have that schema file, project.yaml file, and then the manifest I'll show you later. It can take a bit of time to actually do, so I'm going to go ahead and yarn.install. As you can see, we have a package.json, so there's a lot of node dependencies we need. So I'll actually go ahead and yarn install here to get that running in the background. As that is running, here we have the schema file, the schema.graphql file open, and this is where we define, like I said, our entities. So it defaults to the starter entity. I'm actually going to go ahead and call this transfer. So we're going to make a transfer entity. And again, entities themselves are just like databases would be like a person. So if you had a person entity, the different fields and information can be maybe the eye color, their height, weight, skin color, things of that sort. So for here, we're making a transfer entity. So that's how our data is going to shape around that. And we're actually going to go ahead and get rid of some of these fields. So now we're going to go ahead and define the fields that are required. So the first one is ID. This is required, and this has to be unique. Every entity needs to have a unique ID that we can use it as a reference point for that data. There can't be two pieces of data that have the same ID, because then of course that'd be the same piece of data. So in the spirit of this project, since we're doing transfers, we're going to look for the amount first. And this would just be a big int. And then next we'll do the block number or block height. Again, this would be a big int. And then of course you need a to, which will be a string, and a from, which will also be a string. One thing we'll do is we'll add these exclamation points, and this just makes it where these are required. So at the least, every single entity is going to have an ID. It's going to have a to and a from. That is going to be required for each entity. And now we can go ahead and save that. So we are done installing everything. And now every time you update your schema file, you actually need to go in and run yarn code gen. Of course, this will generate code that is mandatory for your project to run. You need to run that every single time you change the schema file, because if you go into your source folder, you can go into your types and then your models. And there's a lot of indexes. This is just for easier importing. But here we have our transfer entity, which is in the TypeScript format. So this allows us to then add our own TypeScript and the mappings, which I'll show you later, and then access these directly once they're created with the schema file. So here, we have our transfer entity. We have a constructor for that, and that requires an ID. That's that ID I was talking about. And then here are the different fields. So we have what we just defined, the amount, block number, to and from string. You have your save, remove, and get. These are almost like getters and setters, but for more database type, the database type style. And then you have your create. This is just a function that can actually create a new instance of your entity, this being a transfer. So with those down, I will now go into the project.yaml file. Again, this is our manifest file. And here's where, the things we defined earlier, like the description, the repository and stuff, they will be here. We can add it there now. We have our endpoint that we defined. We're using a dictionary, which just helps with quick querying speed. Apologies. And then also we have, we're pulling from the substrate runtime. And then the main thing we'll be editing, of course, are your handlers here. So we have that block handler I talked about earlier, the event, and then also our call handlers. For the purpose of the demonstration, we don't need the call and we don't need the block handler. These are all added by default for the starter project. So whenever you create a new project, you'll have these kind of by default, where you can go ahead and edit what you need and pick and choose what you need. So like I said, we have this handle event, and then we're going to do the module balances and the method of transfer. And so you may be asking, okay, well, how did you know these modules and methods? Where do these come from? Well, there's a neat tool you can use. Let me pull it up, and that is SubScan. So if you go on to SubScan, drag this out of the way. If you go to SubScan, you can see up here on the top in blockchain, you can actually go down to events here. And when you're on events, you can go ahead and filter. So this is what I was mentioning with the modules. Of course, here we'll be using the balances module. And then the event or the method is here. And this, we're going to be using the transfer. So of course, here you can filter everything here. And this is where you can explore and find all different events, whether they're with the council and how many people voted and things of that sort. This can all be found here. So that is a quick way how to find those methods, modules and methods. So we're using balances and transfers. And also I can go ahead and change this from, instead of for handling an event, now we're handling a transfer itself. And with that, our manifest file is now configured. You don't need to, run code yard. You don't need to do the code gen anymore. That's just with the schema file. But now where the bulk of a SubQuery project comes from, this is the mappings file. So here we're importing the substrate and strings it and event and block. These help with the handlers, and we don't need the calls one. We don't need the block. So all we really need is just the event. This is a default from creating a starter project. So we changed this actually to transfer. And you can see it had a really good autocomplete there, which is really helpful. And then balance, which I will go into a little bit later, but we're going to keep that for now. It's very useful. And so with that, we don't need the handle block, as I said, because we're just doing an event. Again, this all just comes by default, so you have a reference point when you're creating your own project. Don't need a handle call. And so now all we're left with is this handle event, which if you remember from our manifest file, we actually called it handle transfer. Again, that's right here, handle transfer. And then with that, I'm actually going to go ahead and delete all of this initial default stuff, because we're actually going to build out our own code to match what we actually wrote for our schema file and then also our in our manifest file. So the first thing we're going to want to do is we're going to make just a few new constants just to pull our data more rapidly. It's going to be called from, which is going to equal event.data and then 0. And so what is this line of code doing? What is from? So event, as you can see off quick cover, is the substrate event we're talking. And then in substrate events, they actually have a record call event, and then that record holds data. And so how do you know what this data is actually representing? Again, if you go back to Subscan here, Subscan has very good documentation for these types of things. If you actually go into the event ID of a balance transfer, you can see here towards the bottom in the docs, it says transfer succeeded, and it's from, to, and then a value. So this is just an array of that data. And so that's kind of that's how you can find what the data array is actually consisting of when you're going to use it in your SubQuery project. So again, that from matches with the first index of that array. I'm going to use a cheeky Shift-Alt-Down arrow. If you didn't know, it's a really good shortcut for code, Visual Studio Code. And I'm going to change this to 2, make this the next piece of data. And then the amount, that's going to be the last index, the third index of that array. With that, we have our variables defined. Sorry about that. We have our variables defined, and now we can actually go ahead and make a new transfer instance. So we're going to say const transfer. We're just going to call it transfer because it's in the scope of this function. Equals a new transfer. And then the big thing is we need a specific ID. Remember, we needed this ID that's required here. That is where, and if you went back to the models of transfer, you need that inside the constructor. You need that ID parameter. That's what this is from, and we're going to actually pull this from our lab book that we'll send you guys later. But it's a longer piece of code that I will then walk you through. And so what this is doing, again, we're back in that event, a substrate event instance. Instead of for going to the event, you can go into the block, and then in that block property, you can go into the block, grab the header, and then grab the number of the header, which is essentially just the block number. Transfer that to an actual number, and then we're just putting in a dash, and then we're doing the event ID. So it's a unique ID to that event. And this, if you're going through Subscan itself, I'll show you again real quick. That can be found here. So it's the same exact format they do. We found it it could be anything, but we found it useful to make sure that we're not replicating any IDs, right? It gives everything a unique ID. This is the block is created, and then that event IDX. So now that we have our transfer instance actually initialized, we can then go in and actually define those fields that we had in the schema file, right? So the first one we can do is our transfer.block number. And that is just going to equal this exactly same, it's going to be the block height again, but instead it has to be, as you can see, it's yelling at us right here, but it actually needs to be moved to a too big int.
You replace the 2 number tray with 2 big int.
Oh, apologies. My bad. Yep. So yep. Just 2 big int there and there. So now it's not to a number, it's to a big int. So next we'll do the from. So transfer.from is going to equal our from, but it's going to be, of course, to string because we're doing a string. Again, I'll just do the cheeky shortcut because I'm rather lazy with it. 2, same exact thing. Just going to be grabbing the variable we made ahead and then just converting it to a string. And then we might as well go ahead and do amount. So transfer.amount is equal to amount. Oh, actually, my apologies. We're going to do amount as a balance. And so the reason I'm using this is pulled from up here. Like I said, we'll be using this later. Amount comes out as a very big ugly number that we can't really understand it. So balance is just one of those interfaces where it just typecasts it. So kind of like how we did 2 big int here, which is bringing it to a balance, which just makes it a unsigned int. So it's something that we can read, the computer can read a little easier. And then of course, again, we have to convert this to a big int as defined in our schema file. So there's a lot of good error checking here, and it lets you know when things aren't matching up if you did the schema file and the manifest file properly. So it's very helpful in that regard. And then the last thing we actually just need to do is we need to do transfer.save, doing that as an await so it can grab all the contents above before it actually calls that function. And with that, so I know that was a rapid fire approach, but in short, again, we're using our handle transfer, which was a modification to an event handler, as you can see here, using substrate event. We made our from, to, and amount variables that we grabbed using subscam to help us out and find what this data array is actually consisting of. We then went in and created our transfer instance, defined the fields in it, and now we are ready to then go ahead and build our project using yarn build. So up until this point, all you really needed was, like I said, a node and a working text editor, and you can have your project built and everything to this point. Build essentially just makes a distribution folder, which makes it easier to actually deploy the project. And then now that we have everything up and running, now we can actually use Docker. So we're going to use a command called docker compose pool, which is going to right here, docker compose pool, which is just going to pool all the necessary dependencies and everything for the container, that is the Postgres server and all the other things from on-finality and such. And then docker compose up, which is actually just going to spin up our container and allow us to start retrieving blocks. And I do want to quickly warn you that this can take a while, at least the first time you do it, because that pool step can take a long time to get through. But after you do it once, it goes through a little smoothly the following times. James, is there anything in particular you want to add while we wait for this to spin up?
Yeah, so there was one question came in earlier. So why would you use SubQuery? And it's quite a simple answer. So we have, as I said at the start, 2 projects. One is on finality. That is a pure RPC endpoint provider. And if you want to query data on chain, if you want to write data to chain, you can just go straight to that, right? And we're doing that. You would have mentioned that we would have seen an endpoint in this project. There was an on finality endpoint. Where SubQuery really comes into itself is when you want to transform that data. So blockchain data is obviously like a linked list. Imagine every page in a book, and to read all the data over the chain, you have to open up each page, read it, and look for the next one. So blockchain data in itself is incredibly inefficient to query across. And this is a very simple example of what we're doing today, right? We're just getting a list of all the single transactions or all the transfers that have ever happened on Polkadot. So it's like what we're doing here is taking all this data that's in a linked list on chain and putting it into almost like a spreadsheet or a database. So it makes it very easy to then analyze and filter and transform. And that's where SubQuery really comes into itself. So if you want to gather data and then query that data from an application, you can query that data directly to the chain, but when you want to add up things that kind of span over blocks or they kind of go over time, like you want to get, for example, if you want to find like the last 7 days worth of staking rewards on chain, you can't really do that directly to chain because there's no existing APIs that will give you that. But SubQuery makes it very simple to pre-index and pre-gather that information because it's continuously running in the background and it's continuously indexing. So what you can see here down in Tre's terminal is that the SubQuery project has started and it's now starting to fetch blocks. And so it will go through and it's fetching blocks quite quickly, but it's fetching from block 329,000 to 402,000. And of that, there are 7 transfer events on those. So it's fetching those blocks running this process that's handles in this function. So for every one of those blocks, it has a transfer event. For every transfer event, it will then send it to this mapping function. And that mapping function controls how the data is changed. In this case, we're just basically saving what's on the data in a different format. And this is how easy it is to build a working SubQuery project.
Yep, no, exactly. Thank you, James. Yeah, so as James just said, we are actually grabbing blocks, and we're only grabbing information from the blocks that have the balances transfer event. And to kind of give another quick example of how useful this can be, you can actually go ahead to your localhost. So localhost 3000, which is what Docker our Docker is running off of, and this is a playground for the actual code that you're writing. So this is actually here. I'll actually go ahead and rebuild this out. So everything first starts off with the initial query, of course. And there's very good documentation that's automatically built as well. So if you're ever confused as where you need to go and what you can look for and actually grab, the documentation on the site is actually really helpful. So of course, we'll be pulling from our transfers entity and then the nodes. So, and now this is where we can actually, based off our GraphQL schema file that we made and altered, this is where you can actually pull and query your information. So again, this is all in GraphQL. So if you're familiar with it, that's good. If not, it's very straightforward. There is the ID. We're going to pull that. Go ahead and pull that amount, the to address, the from address, and then of course we can get that block number that we defined earlier. And if you click the play button, as you can see, it's actually pulling the data. And look how fast that was. That was, those milliseconds, right? And we already have all that data now because of our Docker container, which is essentially like a node, is hosting all that data for us to pull quickly, pull rapidly from. And I do want to preface that the data you see in here, since it's locally, will I don't know if we'll get an update, but it's only going to correspond to what your Docker container has pulled so far. So if you're using a block handler that has to go through every single block, it can take a while for your node to get up to speed to the current block. And so it may not be reflective until later, once you maybe run the node for a day or so, or a couple minutes or an hour.
Should we show ordering by the total amount, or by the biggest transfer event?
Yeah. So another great benefit of using GraphQL is that here we have just a lot of transfers. So you can actually go ahead and, let's say if you just want to do the first, you can go ahead and pull the first maybe 5 transactions here. And now it's only limited to the first 5 transactions pulled. But let's say you can go even further and you can do order by and actually do it by that amount that we had, and we'll do descending till you want to get the highest amount transfers. And as you can see, so far, based off the data we pulled so far in our Docker container, this is the highest amount transferred essentially on the substrate blockchain from this current point. And that kind of just helps and shows the kind of the power with GraphQL and using SubQuery, like how fast this was to grab. And
you can do more, of course. Like you can do filtering as well direct from your query. Think of GraphQL queries as like SQL that you can do remotely, right? So you can add filtering with ors and ands. So we find our customers, if they're building their own DApps, what they'll do is they'll provide a data source that has the data, and then on the client side, they'll do a lot of the filtering. So for example, if we just wanted to show all the transfers that came into your account, or they were into the account that obviously has been used in the app, you would apply a filtering to this. So you'd say the transfers, you might go filter by the to address or the from address equals the current address in the app.
Yes, exactly. And kind of to go a little further in that too, if you have the option with SubQuery to edit your data and your transformation inside the mappings file. But of course, you can always just have it host all your data, SubQuery to host all your data, and then on the back or in the front end, you can go in You know, you can query your data and then format it however you want, using your own formatter. So it's kind of up to you and with that flexibility. But with that, I'm actually going to quickly go ahead and stop this node. So it's done running. And with that, we went ahead and built a project. So hopefully you're able to follow along with that quick tutorial. And you know, now that you've built your project, you know, what can you do with it? Do you want to you don't want to keep your own local node running, and you don't want to worry about the infrastructure and everything. So that's where we have SubQuery Projects. I'm not going to go too in depth in it. There's a good tutorial on our documentation page. It's easily found on our website, but you essentially just put it in your GitHub to where the project is hosted. So you need a GitHub, and then you can just go ahead and host your website with us. And this is our own production grade infrastructure that it is reliable. It is highly scalable and it's high performing. So it's completely free to anyone to host a project, either publicly or privately. If you're maybe testing things, you don't want it to be out there. But it's a great spot where you don't have to worry about the backend node running. You can just create your project, upload it here, and you can then index it whenever you want. And kind of just to recap very quickly, of course, you can use SubQuery to index, transform, and query your substrate chain data. We went in and we broke down the three main parts to a SubQuery project. That is the manifest file, the GraphQL schema file, and then your mappings file. We actually built a quick application that pulls the different transfers and transactions from on-chain data. And then just went through a quick high-level overview of SubQuery projects. And with that, it is the end of the formal portion of the presentation, and we can just open up to any questions here.
There's a couple that just come in. So at the moment, SubQuery is specifically built for Substrate, and Substrate obviously is most commonly used in Polkadot. But there are a lot of other networks kind of being built on the Substrate framework. For example, Compound. Compound is looking at building a Substrate-based testnet called Gateway that they might migrate to. So there's a lot of new things happening on Substrate. That being said, it is kind of a long-term goal to apply Substrate to other chains that are that haven't been served yet. So obviously the Graph is our main kind of a good similar project to us, but they're very specific to Ethereum and very specific to the Ethereum virtual machine, versus what we do is a bit more broader. There was a question, Trey, about just going to explain that line, how we decide the ID for the blocks or for the transfer events. Can you screen share again just to show that part? And
yeah,
the main issue is like we need a unique ID for each entity, right? So we need a unique ID for transfer. And funny enough, you don't actually get the transaction hash in Polkadot till after it's happened. This is why it's done this way in a lot of other projects or a lot of other things like Subscan and Polkascan. All we're doing here is creating a unique ID, and that's based off the block number and the index of that transaction, the index of that event. So each block might only have 2 events, it might have 100 events, and each are given a unique index, which is saved to chain. So it's a way for us to kind of guarantee a unique ID for this transfer. This is using standard GraphQL, using modified versions similar to what AWS Amplify has. I think we are using a flavor of GraphQL. It's pretty similar to standard. I can find out exactly what version it is, or you just could look into our package.json, because I think we're using another package to manage that. But it is using a vanilla version of GraphQL. What is SubQuery not? Well, it needs an endpoint to get data from, right? So like doesn't do anything. One thing that SubQuery doesn't do, and one thing that we've decided and we're very careful about, is SubQuery is what we call deterministic. And deterministic is a kind of a term in computer science, which means that given the same inputs, you will get the same output. And that becomes very important when, you know, our mission or our goal in a year's time is to decentralize the SubQuery network. And so the determinism becomes important there. Deterministic means that you can't bring in data external to chain. You can't bring in current world data because it's not deterministic if that data will be the same tomorrow. So we limit you to what you can put into a SubQuery project to be what is from chain and what is currently stored there. Why not build it in Rust language? As you saw today, it's built in TypeScript. Everyone, like I think most developers out there have at least a basic understanding of JavaScript and by extension TypeScript, which is obviously a bit nicer. Not many developers out there know Rust and understand Rust deeply. Building a SubQuery project, we'll try to make it as easy as possible, right? And you guys, if you're joining the hackathons, you'll notice that every project in the hackathon, whether it's our shared one with Akala, or it's Moonbeam or Fala or Asta, or even I think Antelage has done one, they all have challenges around building dApps, because dApps are the future, right? dApps are the things that these blockchains need. You need good use cases that are intuitive, that are easy to use to access and unlock the value on each of these blockchains. And for all of these, even though we're partnering with Akala to run a challenge with them, even if for all these other ones, you're still potentially going to need to use SubQuery to build that dApp in your challenge. How it pulled the data so fast? Well, essentially, you think SubQuery, when you run it, you say, I only want to know blocks that have the handled transfer event, right? That's what Tre did in the manifest file right at the start. And so the SubQuery project, when it gets going, it will just look for blocks that have that event. So it goes really quickly through the blockchain, because at the start, the first few blocks, there's not many transfer events. It's only after like 3 million blocks in where we start getting a lot of transfers happening. And so the starting part was really fast, but that's because it knows just to look for blocks that have that data in it. In a real project, would I use SubQuery exclusively or mix with an RPC node? You'd mix it. So SubQuery doesn't allow you to update data. It's a read-only view of the data on chain. It doesn't allow you to save data back into that chain. So in a real world project, you would use SubQuery to retrieve data. So if you want to load a list of transactions, you would use SubQuery to get that potentially, or you want to load data on the average APY staking rates. You would use SubQuery for that. And then your application would then save any data or save any changes that you make through the application back to chain via the RPC nodes, and we have them with on finality.
And so, yeah, there's a question here about Visual Studio Code on Windows. Yes, I am using Visual Studio Code on Windows, and it's pointing to Ubuntu via the VSL2. So there's a VSL2 Linux kernel. But if you have Docker up and running on Windows with no errors, then you likely have it working properly. I've tried it with PowerShell, it doesn't work, but I use Git Bash personally. So in Visual Studio, I was using Git Bash, and that terminal seems to work with no problem. So hopefully that fixes your problem.
I'm just going to quickly jump over and just do a quick demo for 5 minutes about on finality and how you can get some nodes from them. So let me share my screen. There it is. So this is on finality. It's a free application. You can get a free account. It has a very generous free tier. There's two main things that you can do with on finality. One is that if you have if you're building a challenge where you're building a blockchain, which many people might want to do in this hackathon, you can deploy a Dockerized version of that blockchain to our infrastructure, and we will deploy that around the world. So you can also take that a step further, and you can deploy your own dedicated node from another team. I'm looking at Kilt here, for example, but if I go back to my playground, you can deploy a dedicated node from many of the big Polkadot parachains to infrastructure. So my internet is quite slow right now. So we've got Edgeware, Carla, for example, Centrifuge, Darwinia, any network out there we generally have, right? And you can deploy a dedicated node for your own purpose, an RPC endpoint. And that would show up like something like this, where you would have this running dedicated node, and you can get the RPC endpoints from that. You can see the information about this validator I'm running for. This is in Polkadot. I don't know if it's currently running right now, but I can get my endpoint to it. But also I can go bigger than that. So I can get an API service endpoint. Running a dedicated node is quite expensive. You're running your own one, and there's a lot of compute and storage requirements for each of those. So we run a globally scalable API service where you can, for each of the different networks, for let's say Moonbeam or Moon River or there's Karura, Kala, there's a Shiden one down here. I think Interlayer has been added soon, but you can get a RPC endpoint and you can make 500,000 queries each day for free. But create an API key, and if you hit the limit, let us know, because we're kind of helping out for the Encode Club Hackathon. So it's a real world scalable RPC endpoint that is just like Infura. It's load balanced, and it's kind of managed at a scale that is a lot bigger than a single node, right? So we're currently doing, if you look at our status page, we are, through these endpoints here, we're currently providing many millions of requests each day, especially to our Polkadot and Kusama endpoints. So this is Polkadot. Yesterday there was almost 50 million, but a couple of weeks ago we had 80 million in one day. Same with Kusama. There was a big spike just the parachain auction started, where we did 229 million API requests each day, which is quite ridiculous. It's a bit lower now. But also Karura as well, we got 25 million a day there. State Mine, Shiden is a bit lower, 10 million, and so forth. So all of these are here to be used by you guys when you need to. Yeah, Marcos asked what weaknesses or major bottlenecks we're looking to address immediately. So as I said, if you want data in a better format, if you hop on Polkadot.js, you can kind of see, like, the reason why it's so slow is because it's making hundreds of requests a minute to chain. Every page needs a whole lot of requests to get specific bits of data for that page. And SubQuery can kind of solve that by, you can get the data in a better format that you need specifically for your app. And we have a lot of projects like Fearless Wallet, which is one of the largest Polkadot specific wallets, use us. Subscan uses us in some parts. We have teams like Subviz, which is a visualizer for the crowd loan data. There's a lot of cool applications that are coming through that are using us to get data on chain. One other thing I might just quickly show you is a Explorer. Tre mentioned this at the start, but it's also interesting to show you what exactly you can get on it. Our Explorer is an online playground where all the different projects that are using SubQuery are shown off. So, for example, you can see exactly how Karura are building a SubQuery project, because by being on this online application, you make your code base public. So I can query the blocks on Karura, for example, they're coming through. I can go into the documentation. I can look at what other documentation they have, like accounts, balances, blocks, calls, decentralized exchange actions, events, extrinsics, Homer actions, which I'm not quite sure is, incentive actions. There's a lot of DeFi related data coming into this because they use this in their app. And I can also go directly into their GitHub and have a look at how they build their project, right? Like, what's their schema file? This is their schema file. It's a bit more complicated than the one that Tre just built for you just now. Their project YAML, for example, they import a lot of types specific to for Karura. This is their type definitions. but also they just have three main mapping functions: a block, an event, and a call handler, because they're kind of indexing everything on chain. So yeah, the Explorer is a great place to go and look at various different projects, whether it's Karura, you know, or things like what PokerSwap uses, and many other smaller ones. How do you get the query data from SubQuery into an app to show? It's essentially, if you want to make a request to this Karura app, for example, this is an endpoint that is running on our managed service, and you just make a post request to that, with your payload being, you know, obviously the GraphQL query, and that's how you get the data. It's very straightforward. It's very easy like that. So for example, I'll show you an application that's using us entirely. Subviz is, as I said, an interesting application that shows crowd loan data, but also auction data. And there's currently a Polkadot auction running that is finishing in a day and 12 hours. So about 36 hours. And I can open up my inspect here in my browser and go to network. And you can see this is request going to a particular SubQuery project hosted on our managed service. And all it's doing is making a post request with the payload being the query. This is a query. It doesn't format well in my browser, but it's essentially the query from what we showed you in Explorer. And in return, they're receiving data. And that data is what then is populated into this page. Yeah, so there are official tutorials. Go to our website. It's called doc.subquery.network. There's information about very specific technical details, like, for example, the different mapping files and manifest files, but also there's a lot of quick start guides and different tutorials and examples. So if you want to see an example of a custom chain, you can look at this one. If you want to see how an example where we use a call handler to index the timestamp that the block is finalized, here's another example. We'll share you as well the code that we've just done and a write-up about it. And then Les has a question around SubQuery seems good for historical data. Can it also be used to get the latest data from blockchain? Yeah, SubQuery, once it catches up to the current block, it's running pretty much at sync rate with the current block. So you can use it to get real-time data. It might be delayed by a second or more, but that is kind of insignificant. But yes, once the SubQuery project catches up to the current block, it runs as new blocks are finalized on chain. And I can kind of show you an example where this is the quick project I've run. It's quite similar to what Trey's shown you. It doesn't show me here what with current block is. Oh, it does actually, sorry. So what is the current block of Polkadot? If it's that, then it's kind of up to date, right? This is the current sync block for this particular project running on managed service. This hasn't been updated in the last few seconds, but every 6 seconds that should change. Excellent. Any other questions? Hunter had a question about compliance. So again, SubQuery only brings data that's on chain. That data is already public. It's already accessible by everyone. We just make it easier to analyze, to investigate. And even a lot of parachain teams use us just to kind of help with debugging their own chain, help with collecting data in a format that they can better analyze and they can improve their chain. So even if they're not building a dApp specifically, we work with a lot of teams to get this data in a format that makes it easier for them to use. All right, Anthony.
Thank you very much, guys. Great workshop, lots of good questions, and thank you everyone for joining. So yeah, we've got the next event is on, I think it's on Thursday at 5:30 p.m. We've got a substrate workshop, everyone, and then I'm leading the way with an ideation workshop next week. If you do have any questions in the meantime, do come and find us on Discord and ask any questions you want. In the meantime, Tre, James, thank you very, very much for your time. Well, this evening for me, this probably morning and afternoon for you both. Hopefully see lots of stuff.
It's a pleasure to be on. And can we join your Discord? Is there?
Of course you can. Let me supply. I can do two things. I'll put you in. Let me send you the link, and I will also give you a special role. Well, at least indicate that you guys are from SubQuery. Bear with me.
And if you guys have any questions after there, I'll put links through the Discord channel, but please reach out and talk to us.
All righty. Well, thank you, everyone, and much appreciated. And we will put the YouTube and the slides up tomorrow morning European time. In the meantime, everyone, thank you very much. Have a good rest of the day wherever you are, and good luck hacking. Bye, everyone.
Cheers. Thanks a lot.